All right, today we are going to review for the 7B chapter test. Just a reminder that this test will be in two parts. Part of it will be with no calculator. So I'm going to model what we expect you to do on the no calculator part. We have a property of logs that says the log base b of b to a power. As long as these two things match, then we basically are left with just the power. The other way to think about it, we can do that little loop thing and say b to some power has to give us b to the fifth. And as long as our bases here match, then our powers have to match. So x would have to be 5. So the answer to log base b of b to the fifth is just the power 5. The second one here, again, thinking of doing that little loop thing, 2 to some power has to give us 32. And if you use your power chart, you can see that that's going to be a 5. 32 is the same as 2 to the fifth. Okay. For the next one, 6 to some power should give us 216. And then again, using your power chart, 216 is 6 to the third power. So here our answer would be 3. For the next set, notice we have a fraction. It's log base 1/3. So now we have 1/3 to some power should give us 1/27. And again, using that power chart, we know that 27 is the same as 3 cubed. So our value here would have to be a 3. We're cubing 1/3 to turn it into 1/27. For this next one, we have 36 to some power being 1/6. And here we're taking a big number like 36 and trying to cut it down into a smaller number. Two things are happening. Number one, we're going from 36 down to 6, which would mean we're square rooting. And the other thing is we are flipping it over and making it a fraction. Instead of 6, we're going to 1/6. So we have a square root and we have a flip. A square root would mean a power of 1/2. To flip it, we would need that power to be negative. Our sixth example here with the no calculator part, we have a base of 1/5. We're raising it to some power to get us back to 25. So now again, we have to flip it. We have to make that 1/5 turn into a 5, and then we have to square it to make it a 25. So we have to flip and square. Flipping means it has to be negative. Squaring means we would need a 2. So we need a power of -2. All right, for this next chunk, notice it says we are rounding to 4 decimal places, so obviously we will be using a calculator for these pieces. We are solving exponential equation here. We have 4 to the x power. We need to isolate that. So the first thing I would do is subtract the 2 over. And then I need to divide out that negative. So I have 4 to the x has to be a positive 64. And then we're really doing what we've just been doing. 4 to some power equals 64. 64 is the same as 4 cubed. So x would have to be 3. This one is an exponential one as well, but our base is an e. We want to isolate that e to the 2x. So my first step would be to divide out the 4. We have e to the 2x equals 21 divided by 4. And I'm just going to leave that as a fraction for now. To undo e to a power, we would need to use the natural log. So we're going to take the natural log of both sides. On the left, the natural log means log base e of e to a power. Those drop out again, and we're left with just the power. On the right side, we have the natural log of 21/4. Our last step then would be to divide out the 2. So x equals the natural log of 21/4, and then that's divided by 2. So let's go to our calculator. We want the natural log of 21 divided by 4. Close that parentheses off, so we're just taking the natural log of that part, and then we want to divide that answer by 2. So rounding to 4 decimals, we would write down 0.8291. All right, Our next one is a log equation. The log is already part of it. So to solve a log equation, we're going to simply convert it to exponential form. So we're going to start with our base of 3, raise it to our power of 5, and it gets us back to our x plus 2. So 3 to the 5th power has to give us x plus 2. 3 to the 5th, using your power chart, is 243. And then subtracting 2, we would be at 241. For question 10, we have to do a little work to isolate this log piece. My first thing would be to move the 5 out of the way, so I'm going to subtract it to the other side. But now I have to get rid of that negative 6. So I'm going to divide that over. So I have the natural log of x equals negative 2/6, or negative 1/3 if I reduce. And now remember, our base when we have a natural log is e. So we are saying e to a negative 1/3 will get us x. All right, grab our calculator. We want to take e, so second natural log, e to a negative 1/3 power. And if you have an older calculator, you might need to put that negative 1/3 in parentheses. We should get a decimal of 0.7165. All right, question 11 is also a log equation, but notice it has 2 logs. We need to condense this down. So addition here condenses back into multiplication. So this is really common log of 4x equals 2. Remember, common log means base 10. So again, doing our little loop, rewriting it exponentially, we would say 10 to the 2nd power equals 4x. Well, 10 squared is 100. 100 equals 4x, so when we divide, x would have to be 25. All right, little typo here. Should say write each equation in logarithmic form. So we're not solving it, we're just converting it to its other format. Again, this could be on the no calculator part. We have 5 to the 4th equals 625. So our base in this case is a 5. It's being raised to a power of 4. So we would say log base 5 of our main number 625 should get us our power. Remember, the answer in a log statement is always the power. So it's always going to equal whatever your power was. In this case, our base is a 4. So we have log base 4. Our power is negative 3, so it has to equal negative 3. And then our main number in this case would be 0.015625. All right, this one has just all variables, but that's okay. We have a base of a, so we're going to say log base a. Our power is b, so it's always going to equal our power. And then our main number would be c divided by d. Okay, the next set, it says write each logarithmic expression as a single log. That means to condense it down. So the first thing I notice here is a subtraction. Subtraction condenses to division. So we'd have the log of 3x divided by 9x. Remember, when we condense, we're down to a single log. We can reduce this. 3x divided by 9x would just be 1/3. So this would be the common log of 1/3. In our next example, we have a number in front, a coefficient of a log, and that has to go back as a power. So this becomes the log of 3 squared minus the log of 4. 3 squared is 9, and we can simplify that subtraction sign into division. So this would be the log of 9 divided by 4. For number 17, we do have to condense. We have an addition here, so that's going to condense down into multiplication. The 1/2 on the outside applies to all of this. So we're going to condense it first. We'd have log base 3 of 49 times x. And then the 1/2 means we're putting that back as a power of this 49x. So we have log base 3 of 49x to the 1/2 power. But 1/2 power just means we're square rooting. So we could square root that 49, simplify this a little bit into log base 3 of 7, and then only the x is to the 1/2. Or again, you could write that as 7 square root of x. All right, the next two are doing the reverse. We are expanding them. So in this first example, I see several things. I see a product, the 3 is being multiplied to the a. I see division with my fraction bar, and I see a power, b is being raised to the second power. So I'm using all three of my log properties. So expanding, the first thing we're going to do is pull apart the division. So log base 4 of 3a minus log base 4 of b squared. Then we can pull apart our multiplication of the 3 times a to log base 4 of 3 plus log base 4 of a. And then we are subtracting log base 4 of b squared. Our powers move to the front of that. So 2 times log base 4 of b. Number 19, again, we're looking at a base 2. We have a product, 8 times the square root of y, and that square root symbol is also a fraction power, a 1/2. So we have log base 2 of 8 plus log base 2 of the square root of y. Now the square root of y means a 1/2 power, so I'm going to pull that 1/2 in front of log base 2, and it becomes just 1/2 log base 2 of y. For the first part, we can actually simplify this down. Log base 2 of 8. 2 to what power would get us an 8? And that's simply a 3. So we end up with 3 plus 1/2 log base 2 of y. For question 20, we are looking to use the change of base formula. That just tells us we can convert this log base 3 into a log that we know. All right, so common log is a nice easy one to use. It's base 10. We have a common log key on our calculator, so it works nicely. So log base 3 of 35 can be converted into log base 10, or the common log of 35, divided by the common log of our base. So the bottom number always goes in the bottom of our fraction. Then we would grab our calculator. It asks us to convert this to 4 decimal places. So we have the log of 35, make sure you close that parenthesis off, divided by the log of 3. And so we end up with 3.2362. All right, the last part that we're going to look at is just a quick review of graphing of logs. Remember that when we graph the logs, we start with the parent function. We want to make sure and put our asymptotes on our graph and at least 3 points in our table. So if we have y equals log base 4 of x, let's rewrite it exponentially. So our base to our power has to get us back to x. So 4 to the y would equal x. That is the function I'm being asked to graph. It's the parent function in this case, since there's no translations or any kind of transformations being done. And the trick to graphing logs is that we can pick the y values. So let's pick some y values, say -1, 0, 1, 2. If we put 4 to the -1 power, we end up with 1/4. 4 to the 0 power would be 1. 4 to the first is 4, and 4 squared is 16. And 16 is going to be a little off my graph, but it says at least 3 points, and I have 3 other ones I can use. So over 1/4, down 1. We have the point 10, we have the point 41, and then we have that point 16.2 out here that we're aiming at. Remember, for log equations, we can never take the log of a negative number. We can never take the log of 0. It has to be a positive number. So we have a vertical asymptote right here at x equals 0. And so my graph is staying to the right of that, coming up along it, and curving off to the right. All right. So make sure that you are staying to the right of that asymptote. That means our domain is everything to the right of 0, so x has to be above 0, greater than 0. And our range for logs is always all real numbers. All right, for our last example, we do have one little translation here. We have x minus 1. That's an h value, which means we are going left and right. Because it's x minus 1, we are going right 1. So we are going to start with the parent function, y equals log base 3 of x. And we're going to make our table of values for that. We have to convert it into its exponential form to make this easier to graph. So 3 to the y would equal x. And let's pick our same y values, -1, 0, 1, 2. 3 to the -1 would be 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared would be 9. So plotting those points, 1/3, -1, 1, 0, 3, 1, and 9, 2. And then our asymptote would be right at the x-axis here again, at 0. However, we are shifting everything right 1. That means the asymptote is going to shift to being x equals 1. My domain then is going to be everything to the right of 1. And my range is still all reals. So let's shift everything right 1. All right, we were at 1/3, -1, a little bit over here. So we are right about there. And we have that vertical asymptote again at 1. And so then my graph would be everything just to the right of that, coming up along it and curving off to the right. Make sure you have arrows on both ends and that you show that it is coming down and following that vertical asymptote. All right, let me know if you have any questions before our test tomorrow.